Today, we're talking about emerging architectures for real-time observability. What does that mean? Well, what we've seen in the past is that there have been end-to-end monolithic architectures. And today, what people are doing with open source, especially with open source analytics, is they're looking to find ways to make composable observability architectures. And we'll get into this in a little bit. Again, I just had a fantastic introduction, but if you aren't familiar with my curriculum vitae, I've worked across data streaming, but also before that on both the OLAP and OLTP side, SQL, NoSQL. And long ago in my galaxy far, far away, I worked for Cisco. So I have this underlying passion for efficient networking systems. So, in fact, why don't you take out your phones here and take a screenshot of that QR code? If you'd like to get the free book, I literally helped co-write the book on open source observability here. And what we're talking about today will follow from a lot of the observations I had from this book and then some. So this is like probably like the second volume of this series. When I wrote open source observability, it wasn't just me. I went out, I talked to more than a dozen experts, people from observability vendors that are based on open source, companies like Netflix and how they're using open source. We just had a talk about ClickHouse, and ClickHouse is huge at Netflix. And so all of this basically was condensed into this pretty short volume for open source observability. But if you like your free book, please go ahead and download it. And I get no commission off of it. It's just great free information. So let's talk about this overhang that we all know is out in front of us, lock-in, the enemy of open source, right? A typical observability vendor wants to own your agents. They want to own your data collection. They want to own your data. So if you ever stop paying your bill, all of your observability data goes split. And it is, RM minus RF star into non-existence. They own your analytics. They'll own the dashboards. And you'll ask, please, Mother May I, can you change this dashboard to accommodate what we're looking for? And they'll say, no, this is the dashboard you get, and it's the one that you paid for. And if it doesn't meet your needs, you're stuck because that's what the vendor gave you. They'll own your alerting. They'll own you, basically, right? You and your organization are at the mercy of this observability vendor. And so when you ask them, well, how did you price out what you offer to me? Because it's not even meeting my needs, they'll provide you with some sort of algorithm that looks something like this. And bonus points in the chat if anybody actually knows what this algorithm, what this formula allows you to calculate. So give me your answers on what you think it is representing right there. But again, it's usually a confusing list of things that are non-predictable often. There's so many surprises in observability. And it's a major issue. And then the other question is this above, below, or about what you expected to pay? So what should observability cost as a percentage of your overall IT spending? And there's no simple answer because everybody's calculating it a little bit differently. So it's a percent of your IT spending, and your IT spending is an overall percent of your overall corporate spending. But what kind of basis are you using for what should you be spending on observability? If you take a look at what Charity Majors, she's been doing a lot of research in this. And so she takes a look at this as a percentage of your infra bill. So what do you consider your infrastructure bill? What is that as a portion of your overall IT spending? Then maybe it's part of your API ops expenses, because that's how Gravity looks at the world. Everything's an API expense, right? If you take a look at AWS, they're taking a look at your cloud budget, right? So what happen? How do you use that if you're actually running on-prem? So you have to consider, like, how do you calculate what it is? But the one thing that everybody can agree upon is, regardless of what this percentage is, it's too damn high, right? That there's this perception that if you're spending anything on observability, you're not spending it on the business. This is a cost that needs to be driven towards zero, which is a challenge for many organizations, but it's also an opportunity for open source, because there, at least, you're taking away the developmental cost. There's still operational costs for the software, but you're taking away the software engineering side of things. So a lot of people take a look at open source and they think, can I hit escape? Can you hit escape? Can you use open source to get out of this lock-in for the observability vendors? Because they're very powerful. They, from soup to nuts, from your telemetry, from the instrumentality of your end systems, your endpoint systems, all the way up to the dashboards at the very far end of it, and the response systems, they want to own the whole thing, and they want all your cache to do so. So how do you break this problem down so that you can insert open source opportunistically and displace what you're paying for commercially with something that you don't have to pay for, that you can just deploy? And where is that appropriate? So in a recent discussion I had with Charity Majors, great person. If you don't follow her on LinkedIn, you definitely should watch her talks. She's trying to understand the business of observability beyond just the technical implementation of how you do it, whether it's a database this or whether it's a, some sort of user interface that, an agent here. Beyond the technologies, there's strategic questions that a CTO or a CIO needs to ask themselves. The classic choice was build versus buy. But now, in the current world, you also have to consider two additional options: commission or integrate. And let me start, in fact, here with the quadrant that you see that is blank, which is avoid. This is bespoke solutions that have no business value. It's the kind of things that, like, an engineering organization decided that they were going to code this up rather than doing it manual old-fashioned way. But there's no value to it. It, like, for them, it was like a passion project. And as soon as that person is not, really gung-ho about this, it'll become abandonware in a second. so, so when you have these very bespoke point solutions with no business value, you want to avoid those as a strategic decision maker. But what you may want to consider, though, is building. And if you take a look at the companies at the frontier of new paradigms like AI right now, people need to build their own AI, or at least their own agentic systems. They'll take LLMs that are publicly available, but they're going to build the logic on top of those systems because that's their special sauce. Dialpad wrote their own AI before the advent of all these massive LLM companies because that was their special sauce for customer support. And when you do build internally, the magical thing that often happens is that a project that was done internally to be a leader, to be a differentiator, then becomes open source. This is where LinkedIn invented Kafka internally to do log aggregation for observability, but then they open sourced that. And now, how many companies don't use Kafka, right? It's this huge data streaming platform that is now ubiquitous across enterprises. Same thing for Apache Pinot, was invented literally down the hall from where Jay Krebs had done Kafka. Kishore Gopalakrishna, he wrote Apache Pinot to be able to ingest and analyze data at the scale that Kafka could generate it. And that was then. They built it internally, but then they open sourced it. And that can be seen over and over and over again. Same thing with Uber. They wrote M3 for their observability stack, and then they open sourced that as well. So building often leads to open source innovation, but it begins with this differentiator that might be some companies don't open source their built stuff. They might patent it. They might use it as a trade secret and not even patent it because then that's special sauce that other people would know about. So building is a key consideration. And it's the exact opposite of being on OSS. Buy, of course, is the commercial off-the-shelf software for observability, which, of course, we all know the big logos there, and we don't need to spend time on them because today we're talking about open source. But the thing between build and buy is what I call commission, which is where you want it to be written for your spec. You'll write up the spec, but you don't want it to be a core competency. So you'll get hired guns. You'll get some engineering IT shop externally, or a consultancy, or just a contractor to write something to your spec. And you'll do that and get that built lickety split because you don't have time to build up those internal core competencies. You just need to make time to market. And it's not available as commercial off-the-shelf software, so it's got to be built to your spec. And oftentimes, a lot of those kinds of things that you commission might also get put back into the open source. Maybe it was a database connector. Maybe it was some sort of instrumentality based on eBPF, and then you'll put that in the open source. So build and commission, I think, are two differentiators that people do put into their IT strategy. Buy, of course, is where a lot of people are just say, like, pay a vendor and we have somebody to scream at. But then in this magical adoption quadrant is you have the choice between open source or source available. And I think a lot of people only talk about open source, but source available, if you take a look at the past decade, there's been this tremendous retrenchment as open source vendors found that hyperscalers were stealing their code or basically using their code to do their own hosted services and then hollowing out those open source communities. And so it's not just Red Panda. We used to have open source, and then when they went to a BSL, but a lot of different companies over the years, especially database companies, have gone to source available instead. But I think that these two kind of live next to each other because the main difference is if you're not trying to resell this software or bundle it into a sold solution, you can just use it internally anyway. It's totally fine. Um, and then the other thing, if you take a look at SillyDB, the interesting choice that they had was that they said, well, we're written in C++ and we've had open source forever and nobody commits to it because it's C++. So we'll make it source available. You can see the code, you can analyze the code, you can see if there's a bug in there. We want to make it source available, but we're not expecting anybody to commit back to the community. So they made it source available. It made their production pipelines easier between their enterprise and their source available code. And it was just a decision that they made. And I think that there's some very interesting things that are still going on. But I want to mention that again, we're talking about open source analytics today. But I think right next to that, adjacent to that, is source available stuff. And I think that we just need to put down some pitchforks about the purism around that kind of thing and really take a look at the reality of how software is afforded to be built in the first place. Now, the good news is that if you're truly committed to open source software and you only want to see the kinds of licenses that you can deploy without legal review, then there's still plenty of options for you in observability. And it goes on each one of the pillars here, from telemetry and instrumentation, data collection, transport, storage, querying, all the way up to the dashboards, right? Obviously, I couldn't be doing this conference without talking about Superset. It's a great way to be able to add your own dashboards on possibly somebody else's data engine, right? So that's an important thing that I think a lot of people need to consider. And that gets into the build or commission element, right? Either you build these dashboards yourselves, you commission a third party, a contractor to make some dashboards for you. But again, you're not going to find like off the shelf. I mean, maybe there will be some templates that you can find open source wise, but a lot of this is going to need to be tailored for your environment. But at least it's built on open source. Grafana has displaced Kibana over the past decade, just raced ahead because it integrates with everything. Whereas Kibana, they kind of held it back by being really only for the Elasticsearch engine. Elasticsearch itself, they removed that open source license, but there's still open source, OpenSearch, which is a forked version of that, right? So you have dashboards, you have telemetry. Again, all of this is open source, and you can take your metrics, your logs, your traces, send that through OTel. OTel can put that into Kafka, and Kafka can take that to the database of choice that you have. We just had a presentation on ClickHouse, but ClickHouse isn't the only destination that's an open source OLAP database. You have Pinot, and if you take a look at big companies like Uber and Stripe, they have huge Pinot clusters. And in fact, Uber took their M3 query language that they use for their M3, which is like their Prometheus plus plus, right? It's this huge metrics engine. But they took M3QL and they put that into open source Apache Pinot. And they added to that a time series query engine. And Pinot also has table joins to it. So depending upon what kind of company that you're looking for, you can choose a time series engine, you can choose a log aggregation or search engine, you can use a real-time OLAP engine, or you can even split these into two, and you can have like Parquet and Iceberg as your data stores, and then a Trino or some other data engine to do the analytics on those files and object store. So it's a very exciting time to make what I call, again, composable observability stacks based upon the open source technologies that you're interested in doing. But here's the thing. Beyond Alert Manager, you want to have much more proactive observability these days. And the way people are taking a look at this is by throwing AI at the problem. It is permeating the observability space. And for your moment of Zen, I want you to consider that there's two elements of this, the yin and the yang of it. For AI, you need observability for AI. And for observability, you have opportunities to apply AI to the observability space. And for today, I'm just going to focus upon we're limited in time, so I'm just going to focus upon observability for AI. But again, I could do another maybe full hour talk on AI for observability. AI observability actually falls into two buckets. There's classic observability and what's now emergent for AI called evaluation. Classic AI observability would be performance tracking, system resource utilization, tracing, clustering, visualization, all that. It would be classic observability. But for evaluation, you're trying to say, is this LLM lying to me? and, or is it hallucinating? Is it drifting? Is it saying unethical things? We've had lawsuits about AIs suggesting to people to do very harmful things to themselves or just illegal things to do, right? So there's data quality monitoring. That's the training data that you're training on your AI against. But then there's also the output side of evaluation, fairness and bias detection. There's a thing called explainability, which is how did from all of this prompt, from all of this data it was trained upon, and from this prompt, how did it arrive at that answer? So explainability is a huge thing to do evaluation against. Transparency. So, does it provide the links from where it got that answer from or not? There's some LLMs that are really good on saying, cite source, and it'll actually tell you where it got that answer from. There's others where you're like, I have no idea where you got that number from. Like, I can't even find it in the source article you provided. Is that a hallucination? For multilingual quality, maybe it's giving you a perfectly wonderful answer in English, but the Germans are all snickering up their sleeves because that's not how you translate that. And we're in a world where the vast majority of people do not speak English. So multilingual quality is also a huge issue for AI observability. And the last two things I'm going to mention here is perplexity. And perplexity is if you were to give a sentence or some sort of number sequence or some sort of progression to an AI, can it guess logically what should come afterwards? So, for instance, for cards, it would be ace, two, king, queen, etc. And then you'd have, does ace go at the front of that segment or does it go at the back of that segment? For linguistics, it could be the quick brown fox jumps over the, and if you were a typographer, you knew that a quick brown fox jumps over a lazy dog because that's how you know that it's going to be using every single character of the English language set. But if you don't have that context, if the AI doesn't understand what a quick brown fox would jump over, then it will guess. And the higher the perplexity, the more randomness there is to the answer it would provide. So perplexity is something like, is it going to give you a predictable answer? Or is it just going to be totally off the wall? And there's also more this Google's algorithm called sensibleness and specificity. So the answer makes sense as it is actually specific to the question that you answered, or is it giving very generic sort of like, I hope you feel better kind of answers? That's not very specific, right? So observability and evaluation are two emerging elements of what's going on with AI. And the good news here is that there's a ton of open source AI observability and evaluation platforms. LangFuse is probably one of the most popular. Phoenix from Arise is also out there. Arise is a huge proprietary platform, but they have a Phoenix, which is an open source package to do it. Helicone, Laminar, Opic, these are a bunch of different things. The only thing I found that was disappointing was that LangChain is open source, but their Langsmith observability tool is not OSS. Only the SDK for it is. But again, this is a whole other hour talk, is to just do a dumpster dive into them. But let me just give you a brief overview of like LangFuse. So it lets you see the sequence diagram of going step by step through how that AI got that answer. And you can see if you read closely enough, I apologize, didn't have enough screen real estate, but you can see how many seconds certain elements are doing and how sub-seconds it hands another process off and another process off, and then it takes more seconds to finally generate that answer and provide it back to you. So you can do tracing of how that LLM gave you that answer. And then you can also take a look at the user base and see who's sucking up all the tokens, which is a key thing. Maybe you're paying for an account and somebody has never used it, so you want to have some sort of user stats as well. So that's what line fuse can do. And here's another cool feature I found in Arise. I remember doing my first 3D graphics in AMSI Pascal back in the 1980s. So I love 3D graphic representations. And here, Phoenix Arise allows you to do dataset clustering visualizations. And again, you get document chunks. You can isolate what's leading to poor performance. And so that's a great little tool that you have there, specifically designed around AI evaluation. This is not just your vanilla dashboard. This is something built for AI evaluation, which is awesome. So as we said that AI is now everywhere, if that's true, well, observability is also everywhere. And so I work at Red Panda, and we see everywhere that people are streaming data. And oftentimes that data that they're streaming is observability telemetry, metrics, logs, traces. And so if you just take a look at our top five different industries that we service, financial services, manufacturing, cybersecurity, ad tech, gaming, you just take a look at those top five. Underneath all of those, there is an observability shadow use case. So for financial services, you might have an API gateway doing your credit card processing or a fraud detection system. And underneath that, you need to have observability to make sure your fraud detection system's not down or your payment gateways aren't down. And then underneath all of those, there's again streaming data constantly. And of course, if you really wanted to get into recursion, there's also observability of your streaming platform itself. So, but we don't want to get into like those kind of fractals sort of thing. But let's take a look at just a typical game company and what they have to do with observability. They have consoles and PCs and Macs and mobile games, and you might need to do crash analytics on the mobile devices. You might want to see where the lag is on the consoles. Is that, and by the way, when you're doing lag analytics, is that based upon the console not rendering quickly? Or is that based upon slow access to the access gateways? Or is that based upon slow response from the back-endian shard servers or the databases? So you need to do this distributed trace across like where is the lag being produced end to end. You have intrusion detection systems, and you'll have metrics coming off of that. You'll have logs coming off of that. Same thing with the authentication servers. And then again, on the business side of it, you're going to have operations dashboards. You're going to have financial dashboards. And you want to make sure that those are responsive and not down during a key critical, maybe it's a 10th year anniversary event on your game. So you want to make sure that everything's looking great and that people can get their prizes and people can, give you more money for the special beastie that you're selling them, a special mount or whatever. So there's observability all the way across an enterprise at many different touch points. And this is just one example. For a game company, for IIoT, you might be doing something on the factory floor, and then you have all the way through to the business side of things. So observability permeates everything. So what's happening then is that you have observability and AI both changing the way companies are running their businesses. You have real-time analytics on top of that and data streaming to nurture all of this. So this is really what the yin yang is. It's actually this symbiosis of multiple different effects going on all at one time. So one of the things we do have that's available for open source is Red Panda Connect. It's so that all of your gazintas, all of those upstream systems, and all your gazatas, all of your syncs and data lakes can all talk with each other. And so we also have, for instance, 16 AI connectors, all open source. We have a couple commercial connectors, but most of the stuff is available for you for free, so that it makes your job easier to stream data between system to system. And what we perceive that's coming out, and if you listen to Tyler Akadow, our CTO, or you listen to Alex Gallego, our CEO, what they're being asked to build today for our biggest customers is what we call the agentic data plane, where there are agents everywhere. There's data streaming from everywhere to everywhere. There's context that needs to be passed from one agentic system to another one. They don't want to have to re-nurture, rehydrate these systems completely independently. So there needs to be a way of sharing data and content and real-time analytics and data streams between different systems. And so we've recently acquired a company called Oxla, which is a Postgres compatible data store, and we're integrating that with the Red Panda platform. But this is not open source, and I want to honor and respect the whole point of this conference, open source analytics. So I don't want to talk too much about it, but I believe that this will be the kind of engine that will unite a bunch of open source AI and a bunch of open source analytics systems together to make a kind of a federated model of how we do this across the enterprise with unified governance and all the rest of it. And that is the end of my rant. So thanks for joining.